Hi, this is Yujie. In this video, I'm going to talk about how to use the reference angle to help us find the trigonometric ratios of angles that are bigger than 90 degrees. We know that if an angle is greater than 90 degrees, we can't draw a right triangle to find its sine, cosine, or tangent directly, but we can use reference angle to help us. Here we have an angle theta and the terminal arm located at quadrant 2, and also the terminal arm intersects the circle with point P. The coordinate of P is x, y, and we can find the reference angle of this angle theta. And from last video, we know the reference angle is the small angle between terminal arm and the x-axis. So here is theta r. Now we have this reference angle theta r. We use this reference angle for our reference to get the trigonometric ratio of theta. So we need a right triangle here. So we draw a vertical line from P down to x-axis. This is 90 degrees. Let's say this point is F. This point is O. We know sine theta r is equal to PF over OP. Cosine theta r is equal to OF over OP. And tangent theta r is equal to PF over F. But this is just a reference angle. We have to go back our original theta. So because P is located on theta's terminal arm, and we get P's coordinate is xy, so xy is related to the angle theta. So in this right triangle, we label PF as y because PF actually is y value, and OF we label OF as x, and this is the x value of P. And because this is a circle, and we know OP is the radius of this circle, so we use R. And in this right triangle, according to Pythagorean theorem, we know the relationship between these three sides. We get r squared is equal to x squared plus y squared. And also we use the reference angle for our reference to solve sine theta. So sine theta, let's see theta r. Theta r is equal to PF over OP. But go back to our original theta, we use y represent PF. So actually sine theta is equal to y over OP actually is r. And cosine theta, and let's say theta r. For theta r, we know cosine theta is equal to OF over OP, but we have used xr, so it's equal to x over r, and tangent theta is equal to y over OP, actually is equal to y over x. And this is how we use reference angle to get sine theta, cosine theta, and tangent theta. Now we can use these formulas to help us with this example. Given the point -3, -4 on the terminal arm of angle theta, determine the value of sine theta, cosine theta, and tangent theta. First, we can draw the terminal arm. We can find where is the point -3 and -4 should be here, and this is P, and -3 and -4. And then we connect the origin O to P, and this is the terminal arm. One possibility for theta is from initial arm to this terminal arm here, and this is theta. But actually, there are many possible angles we can draw. They can go around once, twice, or they can go opposite direction. Even though there are many possible theta, they all have the same trigonometric ratios because they all share the same terminal arm. That means they all have the same y value, r value, or x value. And next, we can find the reference angle. The reference angle is between terminal arm with x-axis, so this is reference angle theta r. We have theta r. Next, we can draw the right triangle that includes this reference angle. So we draw a vertical line up to axis. And in this right triangle, and the length over here actually is equal to y is equal to -4. And the length over here actually is x value, x equal to -3. And here is OP is the radius of the circle, so it's r. So in this right triangle, we know sine theta r is equal to opposite over hypotenuse. But we have to go back to our original angle theta. So we have to use this formula. Sine theta is equal to y over r. We know y value, we know x value, but we don't know r's value. So from the first formula, we know r squared is equal to x squared plus y squared, which is equal to -3 squared plus -4 squared is equal to 25. So r is equal to 5. Here, remember r is a radius, so r always positive value. And now we can get sine theta is equal to y over r. Y is equal to -4 and r is equal to 5. So it's equal to -4 over 5. And then cosine theta is equal to x over r. So x equal to -3, r is equal to 5, so it's equal to -3 over 5. And the last one, tangent theta, is equal to y over x. Y is equal to -4, and x is equal to negative, so it's go to positive, so it's equal to 4 over 3. And this is how we use this formula to solve this example.